If it is not exactly the 90°, it is called as apparent rip. Okay, so discussing about the faults and fault. Okay, discussing about the fault. So we know what is a fault. So this is a fault. Okay, so you have seen this is a fault. Okay, so fault means what? It is basically an undulation that is occurring in the rock, or we can say the bend. See right now here you can see. Okay, the bend that is occurring in the rock is called as uh, faults. Okay, now we have studied about the parts of a fault. Okay, there are different parts of a fault. Okay, let's see this different crust, trough, everything. It's most important. So this we have studied all the parts of the fault. Now next is very important in the syllabus. They have mentioned about the brief classification of the fault. Okay, so here you have to study all the types of classification. Okay, so first of all we'll go classification of faults. Okay, so here based on the shapes, okay, based on the undulated shape, it is classified into anticlines and synclines. You know, anticlines and synclines. From this picture you can see. Okay, so this is an anticline. Okay, so downward picture what you're seeing is an anticline. Okay, okay, so this is an anticline. Right now what you're seeing is an anticline, and this is a down. This what you're seeing is a syncline. Okay, so anticline and syncline. So we'll see what is an anticline. So anticline are the strata arched upwards with the limb, okay, dipping away from the crust. Okay, so anticlines means they are the strata which is arched upwards. So from this figure you can see it is arched upwards. See here it is arched upwards. So anticlines. So the anticlines are the anticlines are the folds which is arched upwards. Okay, which is arched. They are having an arch shape. See here they are having an arch shape. Okay, and dipping away from the crust. So from the crust portion they will be away. Okay, so dipping away from the crust portion. Okay, geologically older rocks occupy a position in the interior of the fault, younger rocks occupy in the outermost flank. Okay, so if you see geologically you can see that in the rock the old rocks will be in the interior, and then outmost outer side you will have the young rocks. Okay, because the rocks is keep on forming and forming. Okay, so if you take a rock structure like this, okay, if you take a rock structure like this, okay, the interior portion, okay, interior portion, that is in the innermost portion it will be having generally older rocks, and if you go to the outermost portion, okay, if you go to the exterior portion you can see that it is having younger rocks. Okay, so in anticlines also you can see that geologically interiormost portion, okay, that means the older rocks will be occupying the interior portions and younger rocks will be occupying the outermost portion. Next one is synclines. So synclines means they are downfalls with the limbs dipping towards the center. See, like this. Okay, with an inverted shape, it will be having an inverted shape. You can see it is dipping inwards. Okay, this is the downfalls. Okay, this downfalls is called as synclines. Okay, synclines. So here we can say that the younger rocks will be occupying the interior of the folds and outer rocks will be occupying in the outermost position. Okay, so just as anticlines in the just opposite. Okay, so in the synclines younger rocks will be occupying in the interiormost portion and older rocks will be occupying the outermost portion. Okay, so that's the one major difference between anticlines and synclines. So see the picture, study with the picture. Okay, see the picture and study with the picture. Okay, you can see here. See in this picture, you can see older rocks is the in the synclines. Older rocks is in the outermost side. Okay, older rocks in the outermost sides, and inner rocks is in the they are having younger rocks. Okay, inner rocks will be having younger rocks. So see So this is anticlines. This will be inclining downwards here. This is anticline. So this is the younger rocks here. So if for the synclines, it will be inclining downwards. Okay, so from this picture itself, we can understand. Okay, if this is inclining downwards, it will be like this. Okay, so this is anticlines and the synclines, how they are occurring. See one more the picture. Okay, this is anticline that is in the Canadian rocks. Okay, another anticlines and synclines that is in the Pennsylvania. Now next one, folds. That's one major classification, that is anticlines and synclines. Okay, now folds are classified based on the six criteria. Okay, we can classify folds based on the six criteria, that is position of the axial plane, degree of compression, behavior with the depth, relative curvature of inner and outer as plunge, and profile of the outer surface. Okay, so let's see first one. First classification of the fold, that is based on the position of the axial plane. So we know what is an axial plane. Okay, so this is an axial plane, you can see. Okay, so the plane which is exactly passing through the hinge portion, or you can say the topmost portion, is called as axial plane. Okay, so this is an axial plane. So depending upon the position of this axial plane, okay, this depending upon this position of the axial plane, the folds are classified into different types, that is around 7 types. So first one is symmetrical, asymmetrical, overturned, isocline, recombinant, conjugate folds, and box fold. Okay, coming to the first one, that is based on the symmetrical folds. Sorry, first one is symmetrical folds. Okay, so here it is normal upright fold. Okay, axial plane will be vertical here, and limbs are equal in length, and dips are equal and opposite, and symmetrical anticlines and symmetrical synclines will be available. Okay, so as the name indicates, symmetrical folds, that means first one, it is exactly passing through the center. Okay, it is exactly passing through the topmost portion, so dividing this fold into two equal portions. Okay, so that is symmetrical. We know what the exact meaning of symmetrical. The max mechanics you have studied about symmetrical. So geometry you have studied about symmetrical, right? So symmetrical means what? Dividing an object into equal parts. Okay, when a plane is dividing an object into equal parts, that is a symmetrical plane. So okay, so first one is here, it is exactly passing through the hinge portion. Okay, so that is it. So limbs will be equal. So these are the two limbs. So both the limbs will be equal, and okay, dips will be equal, and it will be creating and symmetrical anticlines and synclines. Okay, you might have seen. Come to the second one, asymmetrical folds. From the name itself, it is the asymmetrical. Asymmetrical means what? It is not divided into two equal portions. Okay, axial plane has not divided the folds into two equal planes. Let's see what it is. So here, anticlines and synclines whose limbs are of unequal length. So here what is happening? Anticlines and synclines will be having limbs which is of unequal length. That is, see here, symmetrical. This is symmetrical. Okay, okay, so this is symmetrical. Okay, so this is the hinge portion of this fold, and the axial plane is passing through this hinge portion. Okay, so from the figure itself we can understand the limb has not been divided equally. Okay, so this one is more length and this is less length. Okay, so that is, it is dividing the fold into two unequal limbs. That means limbs are not equal. See, this is one limb, this is another limb. Okay, so that is, it is dividing, or this anticlines or synclines, whatever it is, that it will be having limbs of unequal length, and they dip unequally on either side from the hinge line. Okay, and they are, see, the angle of inclination. Okay, this is different. That is, here it is exactly 45 degree, but here they are not creating exact equal length. That means dip are unequal. So this is called as dip. Okay, we have studied about. Okay, this is dip. So these dips are unequal. Axial plane is inclined. Definitely, we have seen the axial plane is inclined. Okay, so that is symmetrical and asymmetrical. Next one is overturned fold. Okay, overturned fold. means it is having an inclined axial planes and both the limbs dip in the same direction. Okay, that is ഒരു overturning nature. The fold is having an overturning nature. That is, here the axial plane will be inclined. Okay, here the axial plane will be inclined, and these two limbs, it will be having a the two limbs will be dipping in the same direction. ഒരു overturning direction. That means ഒരു overturning nature ഉണ്ടാവും. Both the limbs, it will be dipping in the same direction. You can see here. Okay. ഒരേ ഡയറക്ഷനിലാണ് ഡിപ്പ് ചെയ്യുന്നത്. See, they are going parallel to each other. You can see. Okay. So these two limbs, this is one limb, this is another limb. Okay. This is one limb and this is another limb. Okay. So these both limbs are having are going in the same direction. So that is overturning folds. That means it will be having an overturning nature. Okay, so amount of dip in two limbs may or may not be same. Okay, so the dips may or may not be same. Overfolding indicates a severe degree of folding. Okay, so if there is an overfolding, if there is an overturned fold, it means that there is a bigger magnitude of dip. Okay, that means degree of turning is higher. Okay, the dip will be higher. Okay, now limb that undergoes rotation is called as reversed limb and other limb is called as normal limb. Okay, so here you can see this is the axial plane. Okay, so this is an inclined axial plane. Okay, and this is one limb and this is another limb. Okay, these two limbs are turning in one direction. Okay, so the first limb, okay, is called as normal limb, and the limb which is having a turning, you can see here this limb is turning like this. Okay, or overturning pole varum. Okay, this limb will has an overturning, so that is also you can see here this, it will be turning like this, the same direction it will be going. Okay, so our turning limb is called as reversed limb. Okay, so this is overturned limb. Next one you can see here. See, can see here. Okay, okay, next one is overfold. Okay, next limb is overfold. Okay, so see here, if the fold is having a structure like this, a shape like this, you can call it as an overfold limb. That means the top portion will be overturned limb. Okay, so mainly a fold is having two limbs, so one is normal limb and another is reversed limb. Okay, so here the reversed limb, this is a normal limb and the reverse will be having an overturning nature. You can see the other limb has overturned. Okay, so this is called as overfold. Okay, this is called as overfold. I can say overturned fold. So here the two limbs, one will be normal limbs and another limb will be overturned. So that is overfold. Next one is fan fold, based on the fan fold. Okay, so it may be originally either an anticline or syncline. Okay, but extreme compression from the opposite side result bringing the limbs so close to each other that dip condition may get reversed. Okay, anticlinal limb dip towards each other and synclinal limb dips away from each other. So what is happening here, you can see. Okay, this is due to the excessive compressive force that is applied. Okay, is excess of compressive force is applied, what will happen? This a shape like this will be formed. So this is known as fan fold. Okay, this is called as fan fold. This is like, if the suppose if the fold is like this, okay, someone the force is applied like this, excessive compressive force is applied, what will happen? It will be folding like this. Okay, this rock will be folded in this shape, and this is called as a fan fold. Okay, fan fold, that is here the dip condition is getting reversed. Okay, here the dip condition is getting reversed, so that means the anticlinal limb So anticlinal limb will dip towards each other, and the synclinal dip will dip away from each other. See, this is a syncline, it is dipping away from each other, and anticline is dipping towards each other. Okay, so that is fan fold. Due to the excessive compressive force that is applied, it will be having a reversed anticlinal condition, or you can say reversed synclinal condition. Okay, see, this is an example of overturned fold. Okay, next one is isoclinal folding. Okay, isoclinal folding. Okay, so here a group of fold in which limbs are dipping essentially in the same direction and at equal angles. You can see isoclin. So wherever you see iso, you can see that it is something of equal in nature. Okay, so isoclinal means these are actually a group of fold which is limb, whose limb is having dip in the same direction with equal angles. Okay, അതിന് ഡിപ്സിന് ഡിപ്പ് എന്തായിരിക്കും ഒരേ ഡയറക്ഷനിലായിരിക്കും പോകുന്നത്, അതേപോലെ ഇറ്റ് വിൽ ബി ഹാവിംഗ് ഈക്വൽ ആംഗിൾസ്. സോ സച്ച് ഫോൾഡ് ഈസ് കോൾഡ് ആസ് isoclinal folds. Okay, so isoclinal folds means these are the folds which is having uh, which will be dipping in the same direction with the equal angles, that is isoclinal folding. Okay, see, next one is recumbent fold. Okay, so here the extreme types of overturned folds in which axial plane is almost horizontal. Okay, so here one limb lies exactly over the other. I'll show you a picture of recumbent. See the recumbent. This is recumbent fold. You can see here. Okay, recumbent fold. So see this picture. See here. Okay, so what is a recumbent fold means here the extreme types of overturned folds in which axial planes are almost horizontal. Okay, so recumbent fold means these are a type of overturned fold but their axial plane will be horizontal. You can see here the axial plane over here, this is the axial plane. Okay, so this is the axial plane which is horizontal. Okay, so these are actually a type of overturned fold whose axial plane is vertical. Okay, see here this is the axial plane. Here this is the axial plane and this axial plane is vertical. Okay, so here also you can see this is the axial plane. If you see this structure, this is the axial plane. Okay, and this axial plane is vertical, sorry, horizontal. This axial plane is horizontal. Okay, so these are a type of overturned folds whose axial plane is horizontal. Here also you can see this is the axial plane which is horizontal. Okay, so here one limb lies exactly under the other. Okay, so here you can see there, see here this is one limb and this is another limb, this and then another limb. Okay, so one limb will be lying over the another one like this. Okay, so this is one limb, this is lying over another, this is lying over another, this is lying over another. Okay, okay, now main parts are arch, shell and core. Okay, so recumbent is having mainly three parts, that is arch, shell and core. So arch means the zone of curvature corresponding to the crust and trough in the upright fold, and shell means the outer zone almost made up of outermost zone made up of sedimentary formation, and core means innermost part of the fold. Okay, so arch means what? See, this is an arch. You can see this is the arch portion. Okay, the zone of curvature. Okay, so likewise in crust and trough we'll say this portion is called as arch. Okay, this portion is called as arch, that is this zone of curvature is called as arch. Next is shell. Shell means the outermost layer is called as shell, which is composed of sedimentary rocks. Okay, this outermost layer of this recumbent fold is called as shell. Now core means innermost part. Okay, the innermost part of this fold is called as core. So mainly for recommend fold, you're having three parts. First one is arch, then the shell and core. Okay. Next one is conjugate folds. So conjugate folds, so these are the pair of folds that have mutually inclined axial plane. Okay, so these are the folds which is having a mutually inclined axial plane. See here. So this is a group of folds which is having a mutual. See, you can see here one axial plane is passing like this. That's another inclined axial plane. Another inclined axial plane. Here also you will get an axial plane. Okay, so they are mutually inclined to each other. You can see the picture, real picture. Okay, so you can see here mutually they are having mutually inclined axial plane. So that is conjugate fold. Next one is box fold. Okay, so box fold. From the name itself, we can say that bolt with exceptionally flattened top and steep inclined limbs. Okay, almost forming a three sides of a triangle. Okay, so box basically box is having this shape. This is the box shape. Okay, so the fold is having which is having approximately a shape of a box is called as box fold. Okay, so here you can have here in this fold you will have a flattened top. You can see here you will be having a flattened top and a steeply inclined limbs. Okay, steeply inclined limbs. These are the limbs. Okay, ഒരു flattened top and steeply inclined നല്ല ചെരിവുള്ള രണ്ട് limbs. This is one limb and this is another limb. Okay, they're forming almost a shape of a rectangle exclusive of the bottom side. So that is box fold. See, this is a box fold. You can see here. This is a steeply inclined. This is a flattened open like this. Okay. Okay. So that's it. So that's the main classification based on the position of the axial plane. Next one is coming to the degree of compression. Okay, coming to the how much of compression has been applied to the rock. Based on the degree of compression, we are having open folds and closed folds. Okay, so see this picture first. Okay, now open folds means the folds in which thickness of the rock is not affected during folding. Closed fold means folds with a thickened crust and trough with thinner limbs. Okay, so based on the degree of compression, that means how much of compressive force is applied. Based on that, it is classified into open folds and closed folds. Okay, for open folds, thickness of the rocks. See, thickness of the rocks are not affected during folding. Okay, so this is the open fold. Okay, so this is an open fold. Okay, so here the thickness of this rock is not affected during folding. So folding means what? The force will be applied over here and it will be having some bending shape. So while the force is applying and while the rock is forming into a bend shape, the thickness of the rock will be unaffected. Okay, the thickness of the rock will be unaffected. That means there will be no change in the thickness of the rock. Coming to the second one, closed folds. Okay, coming to the second one, that is closed folds. You can see fold with a thickened crust and trough and thinner limbs. Okay, that is when some excessive pressure is applied. You can see here like this. If the excessive pressure is applied, the shape will be like this. That is the limb portion. Okay, so this is the limb portion. The limb portion will be thin and this top portion, this crust portion will be thicker. You can see from this picture. Okay, so this is the crust portion. This crust portion will be thick. Okay, this crust portion will be thick, and if you see the limb portion, see the limb portion which is thin. That is due to the force that is applied. Okay, so this is open fold and closed fold. Okay, that is limb portion കുറച്ച് മെലിഞ്ഞതായിരിക്കും. At the same time, you can see the crust portion, it will be a greater thickness. The next one is based on the behavior with the depth. Okay, classification based on the behavior with the depth. Okay, so folding may involve a strata for considerable depth. Okay, based on the depth, that is concentric folds, similar folds, and suppurative folds. See the figure. Okay, see the figure. Okay, see the figure and then we'll study. Okay, so based on the thickness. So analyze the thickness. First one is concentric folding. Next one is similar folding and superficial folding. Okay, coming to the concentric folds, it is also called as parallel folds. So here thickness of the layer remains same even after the folding. Okay, so even if this thickness, see, so even after the undulations has occurred or even after the bending has occurred, the thickness of the rock has not changed. Okay, the thickness of the rock has not changed. Thickness will remain same. Okay, so such folding is called as concentric folding. Okay, that is when a force is applied, the rock will form into a bend shape, and that bending is called as folding. Okay, and during this bending, if the thickness is of same or if the thickness is constant, it is called as concentric folding. It is also called as parallel folds. Second one is similar folds. Okay, in similar folds, folds for which a degree of folding is similar for indefinite depth. Okay, that means here the degree of the folding is same for any number of depths. See here. So here the degree of the folding. Okay, that means how much the degree of folding has occurred in each depth will be same. That means here, for example, here you can see three depths. Okay, this is first depth of this rock. This is another depth, we can indicate it as T2. This is another depth T3. Okay, so all these three depth 1, 2 and 3, all these three strata, okay, or the depth of all these three strata will remain same. Okay, that means degree of folding that is applied to each depth will be same. Okay, if that is for indefinite number of folds. Okay, that is എത്ര number of layers ഉണ്ടോ അത്രയും layers-ലേക്ക്. Okay, that is folds for which degree of folding is similar for indefinite depths. Okay, so how, see, it will be having a number of depths like this, number of beds like this. Okay, for all these beds the degree of folding will be same. So that is similar folds. Next one is superficial folds. So here folds which are showing difference in thickness at the crustal and trough regions occurs in erosional depositional process in the folded regions. Okay, so here the folding, the thickness will be different for crust and trough. That means the crust portion and the trough, if you consider the crust portion and trough portion, the thickness will be different. Okay, the crust portion and trough portion thickness will be different. So that is superficial folds. Okay, so this is mainly occurring due to the erosion and deposition of the sediments. Okay, so superficial fold means it is showing it is a fold which is having a different thickness in the crust portion and trough portion. Okay, so that is superficial folding. So that is based on the depth. Next one is based on the relative behavior of inner and outer arcs. Relative behavior of inner and outer arcs. So here mainly it is classified with three, that is class 1, class 2, class 3. Okay, so based on the relative curvature of inner and outer arcs. So in the class 1 folds, a degree of curvature in the outer arc of the fold is less than that of inner arc. See the class 1. Okay, so that means degree of curvature for the outer one. Okay, you can see this is as A. Degree of curvature for the outer one will be less than that of inner one. So here this is having more curvature. So here curvature is less. So it is classified into class 1 fold. Now coming to the class 2 fold, degree of curvature for the outer and inner arcs will be same. You can see both outer arc. So this is the outer arc and this is the inner arc will be same. So that is classified as class 2. If you go to class 3, the degree of curvature of the outer arc is greater than inner arc. That means here what is happening? This is the outer arc. Okay. So here the outer curvature is more than that of inner curvature. Okay. Outer curvature will be more than that of inner curvature. So that is classified into class 3. Okay. So that is relative curvature. So that's the classification based on the curvature of outer arcs and inner arcs. Next one is based on the plunge. Okay, so we know what is a plunge. We have studied about plunge. Okay, so you're having based on the plunge, it is classified to plunging fold and non-plunging fold. Okay, so that is mainly based on the horizontal axis. Okay, so this is plunging and non-plunging. Okay, so here in the plunging fold, it may be any fold in which axis of the fold is not horizontal. Okay, so plunging fold is a fold where the axis of the fold is not horizontal. See this one. So this is plunging fold. Okay, plunging fold. Okay, so you can see this is here. This is the axis of the fold. Okay, and this axis of the fold here it is vertical, and here you can see it is inclined. Okay, here it is inclined. Okay, here it is exactly vertical. It will be inclined. Anyway, it is not horizontal. Okay, so whatever may be the folds, if the axis is not horizontal, it is classified as plunging fold. So what will be non-plunging? Definitely a fold where the axis will be horizontal. See here. Okay, if the axis is horizontal, you can call it as non-plunging fold. Okay, so that is plunging and non-plunging. Okay, so see. See, this is a 3D, three dimension of an axis of fold. So this is it, fold axis. And last one, that is based on the profile of the outer surface. Okay, last one, that is based on the profile of the outer surface. So it is classified as chevron fold, conjugate fold, cuspid folds, and cylindrical folds. So coming to the first one, that is chevron folds. So chevron means it will be having a well-defined shape, that is usually it is having a V shape. Okay, usually which is having, this is chevron folds. It is definitely having a V shape. Okay, it is definitely having a V shape. Okay, so chevron folds are the folds which is having a well-defined sharp hinge points and straight planar limbs. Okay, so here this is the hinge points. This will be the hinge points, and the limbs will be straight. Okay, limbs will be straight over. That is exactly they'll be having a V shape. So that is chevron folds. That is hinge points will be very accurate, or hinge point will be very definite, and the limbs will be straight. Coming to the second one, that is conjugate folds. So conjugate folds, here the composite folds with the two hinges and three planar limbs. So this central limb is exceptionally flattened. It will be almost similar to a box. See this one. So in this fold you can see here you are having two hinges. So this is one hinge. Okay, this is one hinge and this is another hinge, and number of limbs. If you see, this is 1, 2 and 3 number of limbs, and almost the top limb will be flat. So this type of fold is called as conjugate fold. Okay, this type of fold is called as conjugate fold. Okay, next one is cuspate folds. So here the limbs are not planar, it will be concave upwards or concave downwards. See here. So this is a cuspate fold. Okay, so cuspate fold means the inner side will be concave. So the inner side will be concave and the outer side will be convex, like this. Okay, so concave, convex, concave, convex. So this type of folds is called as a cuspate fold. Okay, so here the limbs will not be a planar. Next one is cylindrical folds. Okay, so cylindrical folds, on the name itself we can understand something that is related to cylinder. So it is having a shape of a pipe. Okay, so here the fold is having a shape of a pipe and they'll be having a well defined axis of the fold which is parallel to each other. See this. So this is cylindrical fold. Okay, so here you can see it is almost having a pipe shape. So here it is having an apparent pipe shape, and here the axis will be very well defined. Axis of the fold axis will be very well defined. Okay, so this is the fold axis. Okay, so this is the fold axis. Okay, almost time now. We'll discuss the next class. You can post your name to mark the attendance.